Look, I'm just come down from the beach. That's the danger of going to a conference in Brighton, I guess. So hi, thanks for coming to my talk with the title of Looking at AI as a Creative Partner. And then today we're going to use the term AI in the broadest possible sense. So any piece of software that can do anything that seems like remotely independent will qualify as AI today. So it can either be that the AI can take its own initiative, or more often, the AI will react in something or in response to something that the human is doing or the user is doing. So before we continue with today's topic, I'll just introduce myself. My name is Gorm. I'm a senior engine generalist programmer. I worked in the games industry since 2004, and I've sort of slowly evolved into the human version of a Swiss Army knife. Very generalist engine stuff. I worked on big and small game projects on a lot of different platforms, and I've always had a foot in academia, even when working in industry, and published and did guest lectures. And then in 2018, I joined the PhD program on intelligent games and games intelligence at Goldsmiths. So if anyone are interested in the program, there's an IGI booth up in the expo hall. All right. So today, I'd like to talk to you about how procedural content generation and AI-assistive methods can do more than just automate tasks and let you produce more content for your games, or conceptually produce more content. We'll get into that later. I hope to convince you that by seeing the computer as a creative partner, it can help developers get more ideas and become more creative. So as developers, we like to have control of even the smallest details. So for this to work, you'll have to think of the application as more than just a tool, really. It has to become a colleague that can give you ideas, or that can work with you in an iterative loop until you're happy with the outcome. Or you can imagine it's almost like talking to someone over a water cooler. What if you did this? And instead of you being a little bit, or us being a little bit annoyed, you do something and you think, why did the computer do this? Then give it a chance and think, maybe I never thought about it doing that. So you already had a quick introduction to the topic. This is the agenda for today. We'll have a quick look at the source material for this talk, which is a paper my supervisors and I got published into a journal called the Transactions on Games. And then we'll quickly move into some examples of assistive AI applications. And then finally, I'll introduce you to a couple of common design patterns and challenges when designing AI-assistive applications. Again, the paper that inspired this talk will have a lot more. And then in the end, we'll look at some future areas and sorts of directions to work on and research. So as mentioned in the beginning, this talk is really sort of an industry-friendly digest of a little bit of my PhD research. And the full article is on open access and can be downloaded for free on the IEEE website. In one way, this is actually on the coding track, but today's content is more sort of like a designery version. It's not going to have a lot of technical, or absolutely almost no technical details whatsoever. But if you go into this paper, you'll have a lot more detail, and you can read about the methods and which algorithms, or in some cases, machine learning methods were applied, and that sort of stuff. The paper also identifies more design patterns and challenges than what we're going to talk about today. Okay, so in the beginning, the initial promise of tools for procedural content generation was that we can create more content faster. However, as game developers, we know that the devil is very often in the detail. So game development has always been about getting those tiny details right. Not only sort of like the mechanics, how we jump, but also how things move and animate, how everything looks, the distribution of trees. Where is the small grove exactly in the forest? An artist might think, no, this tree is rotated slightly wrong. I like it to be like this. So in that way, we all seem to always be fighting PhD tools a lot. And especially with earlier PhD tools, this is true. But also with contemporary ones, there's been a lot of a trade-off between making a lot of content and creative control. So that's still something that's very true. Some tools like Houdini seems to be doing strides in sort of like bridging that gap, but there's still a lot to bridge. So on top of that, we also have game developers. There's the pressures on the markets. So combining with our own personal ambition. So we want to make more, and we have these procedural content tools that promise us we can make more. So our ambitions grow, our costs grow, our teams grow. So as the tools allow us to create more content and create bigger and more open worlds, we also try out more combinations of something because we can. So games are in many ways still more expensive to create than they have ever been, and they're created by bigger and bigger teams. So as I talked about, there are glimmers of hope, but generally it's true that we haven't really, PCG hasn't really delivered on its promise of cutting costs and production time. So instead, what I'm going to argue today is that the main strength of procedural content generation is to give us inspiration and push back on us with ideas if we will allow it. So it will only work if we start thinking about the software, the computer program, the AI, if we want, the computational agent, as someone who can give us ideas. Exactly like if we were in a meeting with a human colleague or discussing details over a cup of coffee. So going back further and thinking about these AIs or computational agents, I'm old enough that I remember Clippy, which was Microsoft's Office assistant in early versions. And Clippy wasn't really very helpful, and at the best of the times, a little bit annoying, and the worst of the times just got in the way. So that wasn't really how to do it, but there was a very early attempt. So now I'm going to talk about some more examples that come from the research community. These are a lot more. There's a lot more in the paper, and there's also a lot more out there than my paper doesn't cover. So the first one is something called the Evolutionary Dungeon Designer. It is developed through a large series of papers, and it's still going on. So what they first did was they looked at a lot of games, 91 games, and they distilled game design patterns from them, micro, meso, and macro patterns. And then they created a tool that could highlight different patterns and automate the generation of dungeons. So the evolution of the dungeon design can help you generate dungeons. You can just press a button, and it has something called, it uses a method called mutant shopping, which means it generates some methods, some suggestions for you. You can see, for example, 3 suggestions here, and then you can pick one, and that becomes your new template you can work and edit on. And then if you like that one, then it can generate from your suggestion, it'll generate 3 more. So it's sort of like an evolutionary algorithm, but instead of having a fitness function so a fitness function is like something that measures what the best outcome is, right? So if a typical fitness function could be like, how fast can we walk in 10 seconds? Or how far can we walk in 10 seconds, right? So in this, what is the best dungeon would be the fitness function. In this case, it's not a computer that decides, it's the human. So every time it takes your choice, and then it generates something new from your choice. And that's what's called mutant shopping. Others have called it gardening, and others even have called it choice-based interactive evolution. But it basically covers the same concept. We'll talk more about that. That's a very common pattern in these kind of tools. You can also edit parts manually. So you think, oh, this is a nice dungeon. It has parts I like, it has parts I don't like. So you can lock down parts of it, and then other parts it will regenerate around you. Sort of like DALL-E also can do, expands things. Some of these like modern image generator we're going to talk about. The tool can also highlight different game design patterns and focus on, is this particular dungeon focused on monsters, or is it particular dungeon focused on treasures? So it can also distribute them for you. So it can do these kind of things. So one thing that it allows you to do, which we'll also talk about later, is it's really good at generating these things, but there is, as we talked about, humans really like control. So it also allows you to override and do some manual edits, which is sort of like the PCG cop-out, you can say, because if it takes too long to converge on something you want, then you think, oh, fuck it, I'm just gonna go in, lock this down and do some manual edits. So it's exactly like how I want it to be. Sorry for the So another editor is Procedural. I forgot to put a picture here. So it's the editor for a game called Cut the Rope, which some of you might know. It's sort of like a casual game. You have a little monster, and then you cut a rope, and then it can jump down, and you have to get it to the candy. So you cut some ropes, and then there's some physics that make him swing, or some rope swing, some contraption swing. So Procedural is a mixed initiative tool, which is AI-assistive tool for creating and solving cut the rope levels. And the authors made two different versions of it. And in the first one, the levels evolve according to a set of fitness measures, which is sort of like they try to find the optimal placement of contraptions and now I forgot the tokens and units on the map. And then they also have a second method, which is an action-based method that is combined with physical simulation, which means that they can actually test if the level is beatable and playable. So you generate something, and then the game will tell you, this level can actually be completed. Of course, one important thing is it can generate a level and test for you if it's beatable, but of course it doesn't mean that it's a particular good level, or it is a level that matches the kind of difficulty that you're looking for as a designer. It might be too hard or too easy. So there's still a little bit of work for the human designer. Now, ZooSketch is a recent work which is quite interesting because it generates level for first-person shooters. So there's a lot of 2D things, and ZooSketch is one of the first one that's sort of like procedural content generation or level tools for procedural generating game levels that jump into 3D. So they're saying, what else besides just the layout do you want to know? So it has 3 different tabs up here that can sort of like, it has a map tab, it has predictions and different suggestions also that you can do, and then it can predict the dramatic arc of the game, It can predict the pace of the combat. How is it gonna be slow in the beginning? How is it gonna evolve and it's gonna be fast? Which side are gonna dominate on this map? So these kind of things is something that the AI can help you with, which I can imagine would be incredibly useful for a designer. Okay. I'm running through these methods. So Tanagra is a tool for designing 2D puzzle platformers. We have it here. It's a mixed initiative tool for creating and playtesting side-scrolling 2D platform games. It allows the user to design parts of a level and then have the AI fill in the rest. So maybe you just have a small section here, think, this looks good, can you do the rest for me? And then it designs the rest of the levels around you. Or you can also go in and see, actually the AI is not done exactly the level here I don't want. That's sort of like big jump here. So you can go in, you can start editing this, and the tool will automatically adjust the levels around you due to some constraints you've defined. So you can start editing here, and it will modify the level around you so that the level is always beatable. Again, just something to help you along and make sure that the game is always playable. Yeah, and then it has a lot of like other standard things, like you can modify jumps or removing jumps and change the pacing and those kind of things. Okay. So the Sentient Sketchbook is a tool for designing RTS games. Again, it uses mutant shopping, so you have you're designing a map, and it comes up with different suggestions that you can choose between and replace your current sketch with, depending on what you're doing. Again, it can also test if a level is playable, and the user can edit a high-level map sketch, so you work on sort of like a macro level, not the very fine details, and you can place spaces, resources, impassable tiles as the user is editing the map. And while you're doing this, the co-creative AI is coming up with alternative map suggestions and judging the current map and making 6 different suggestions using different measures that you can pick between. And again, also it tests always if your map is playable. Are you actually able to reach the enemy base on this map? So this is sort of like a very macro view of the game, right? So you can still zoom in. And up here are some different suggestions. And if you like one more than the other, then you just click it and replaces it. And then based on your choice, it's going to generate more. Again, sort of like evolutionary human algorithm, human in the middle. So the tools we've talked about so far have all been level design tools. The interesting thing about refraction is that it's a tool for, instead of designing a single level, you can just use it for designing a progression of levels. So you use it for saying, this is how difficult it's going to be. You have a slider, so you can adjust across the difficulties and content, so like simultaneously across all levels. The authors used the tool for creating a little puzzle game to teach fractional math using constraint solving called refraction. But it's quite interesting because it's just looking at a single level of things. Okay, how can we actually, the designer plans the entire game and the progression as the player progresses from one level to the next. So far, we only looked at tools for creating content. But of course, there's also games and a lot of research that create content on the fly. And one of these games is Galactic Arms Race. So Galactic Arms Race is a 2D shoot 'em up where the content adapts to the user playstyle. Specifically, they have these particle-based weapons that are constantly evolving based on what the player uses. So it's not the graphical style of the weapon that evolves. Instead, it's the ammunition, the color, and the movement pattern of the emitted particles. So it's all based on a neural network, and it takes in your distance to the firing position and these kind of things to evolve your weapon. And then the fitness of the weapon is based on how often it's used. So not if you pick it up, but you actually also have to use the weapon. And then if you don't use it for a while, the fitness degrades over time, which means that basically the game is going to stop looking at it as something worth evolving, right? So think, okay, this game, the player is not so interested in this weapon anymore, so I'm going to continue evolving some other weapons that the player is using instead. A very interesting recent development, not for level design, but for editing code, is Copilot. It's a project by GitHub. It's based on work by OpenAI, and it's now offered as a commercial service by GitHub. So you can pay $10 a month to get access to this, and they trained a machine learning algorithm on a lot of the, I don't know if it's all of it, but a lot of the open source code on GitHub, which is, I mean, if you ask me, it's still it's a bit sort of like legally dubious, but they seem to be getting away with it so far. So they have had all this code on GitHub that they trained their neural networks on, and from that they made a network that can write code for you. So in this case, you can just say, make a comment that says find images without an alt attribute if you write in JavaScript, and give them a red border, and then boom, it generates the code for you. It's quite amazing what it can do. But of course, yeah, the code that it has been trained on is all copyrighted, even if it is open source. So they're now making money on other people's work, but it is quite an amazing thing to work with. And at least for more simple functions, I imagine it can be very helpful if you just want a utility function to do something. You think I've written this a million times before and I don't want to do it again. and then it does that for you. That can be incredibly helpful. So something that's really been very, very popular lately is that's been all over Twitter is image generators. So there's been all these what do you say, like no, I forgot the term, but language sort of like language interpretation models has been humans big strides in. So for example, there's a game that you can play that's called AI Dungeon. It's a text adventure, sort of like in the old Infocom style. And you can basically write anything you want in response. It doesn't only understand east, west, and north and like pick up, but you can say, oh, the game might tell you, oh, you're on a stranded island and you see a big statue in front of you, and you can just say, okay, I take my moon boots on, or my cape, my magical cape on, and I fly up and I look at the island from the top, and it will come up with a response to you. Maybe it will allow you to do it, but maybe not. But it will respond to you in a mostly meaningful fashion, not always. But it's quite fantastic, sort of like this sort of like weird games that you can work on. You can come up with that way. So those sort of like text models have that takes the sentences input and can at least gather some kind of like semantic meaning from almost everything. People have taken those and they have made image generators. One very famous one now is called DALL-E, but there's also others. There's DALL-E that has a waiting list. Midjourney is in open beta. You can join now on the Discord, and you can just write in a sentence and it'll generate something for you in 20 seconds. Unfortunately, this section is not in our paper because the paper that most of this talk is made from was already submitted last year when some of these were not so hot at the time, but academic publishing can be a bit slow. So the paper has only come out now. So this is some of the examples I played with this yesterday. And I just thought, okay, let me see what it's going to give me. So here I just put in a text saying, a solar punk image of a destroyed nuclear power plant overgrown with plants. And then it just gave me these 4 images. It's quite amazing what it can. Or since we're in Brighton, I thought, okay, a sunny day by the pier in Brighton. So these may not be, the point here is that these may not be images that we would want in our final game, right? But they will give you ideas, and you think, if you allow them to, you could say, oh, maybe I didn't think about that, or yeah, maybe it's interesting if the pier looked like that, if you're a modeler or something like that, you know, just to sort of like allow a little bit of reflection what it can generate for you. Also, most artists I know, they have a big archive of material, inspirational material that they scour the internet from, or they take photos on their holiday or whenever they're out walking. And in the same way, these image generators can do the same, right? You can just use them to generate inspiration. Here's another one that gave a little bit of a weird output. I thought, where I said, a long-haired warrior sitting on a rooftop looking down on a bustling medieval city full of traders. And then when I just did that, we actually had sort of like the character here was sitting on top of a rooftop looking down in sort of like more an Assassin's Creed fashion without being super enlarged. But then when I added, there is hope in the image, but also despair, it took some creative freedom and sort of like made this like giant figure that looked down and made an artistic interpretation of what it means that there is hope, but also despair. So that's Midjourney. The most famous one, probably at the moment, is DALL-E, and there's DALL-E 2. And DALL-E 2 has been used, based on textual interpretation. In this case, we have the Cosmopolitan magazine. They work with OpenAI to create this front page. So it's also something that has taken iterations. It's just not someone, I mean, this amazing image is not something that someone at Cosmopolitan has just written in the sentence that says, a wide-angle shot from below of a female astronaut with an athletic feminine body walking with swagger toward camera on Mars in an infinite universe synthwave digital art. And then it came up with this. Maybe it did, but they have worked on with them. There's been a lot of ping pong to come up with this image. But still, it is quite amazing what it's done, and it's all done by an AI. in the end. So I think maybe even, again, even if we can generate something like this, I imagine that the people always will want to have some, as a human, we always want some artistic control, and we have an idea of where we're going. So again, this might be that we get some ideas for what we want to do if it creates something like this. I imagine it's rare that we actually want to take exactly what it comes up with and put it in the game. Some of them also have constraints. So for example, we see the face of the person here is slightly distorted because they're trying to avoid people making deep fakes and those kind of things. So you can make an image that looks like, you can see it's Jarvis Cocker, but you can't get his face superimposed. So one thing that, so some of the sort of like common patterns that come up all the time in papers are the ability to override the AI and mutant shopping, which is where the application shows you alternative designs to what the user is currently designing. You saw even the image generators did this, right? So they come up with some different suggestions, and here you can also evolve them further, and you can say, oh, I really like this one, make me another version, give me 4 new suggestions based on that. Yeah. So what happens often is that many researchers, they don't have this ability to override the AI in their initial works. And then when you read their next papers, they've done some user surveys, and then the constant feedback is, can we please get the ability to override the AI? Which is, and then they do it in the end often, or at least in some cases. And to me, it feels like a bit of a cop-out, but it is also a very honest design pattern, at least, that while the tools are useful in some circumstances, it's still very early days in PCG, and we haven't really found the optimal way of sort of second guessing the user. Even if we can see what they're working on and we evolve in the direction of the user, we don't know exactly what the people in this audience are thinking all the time, right? And what you want to do creatively. So sometimes it is needed to just let the user have the ability to either completely disable the AI or at least override parts of it. So there's this technique also when we go to mutant shopping. Recently, so Compton and Matthias call this mutant shopping. Others like later, who's in the audience, my supervisor, call this gardening, which is basically that you have that shows you different options, and you think, oh, I'm gonna pick that option, and then it gives you more suggestions in that direction. Of course, the sort of like the weak point about this is the mutant shopping and showing you suggestions is user fatigue. So the AI comes up with something, and you think, oh, it's nice, but it's not quite right. And then you click the evolve button again, or new suggestion. You make like maybe a small suggestion, more green, please. And then you do it again. And, oh, okay, this is better, but not quite right. And after you've done that like 5-10 times, you think, okay, maybe I should change task or just do it myself. Interesting tool, but so that's sort of like what we call user fatigue. Basically, if it has a problem in converging on designs that the human designer likes, right? Because again, it might not get close enough. And there are also other times when the computer just simply takes too long to respond. This is exemplified in what Compton calls the grok loop. Also, other people have made similar models. So we have sort of like an expectant. Let's see. So we make a hypothesis of what we want to make. Then we based on that, we modify what the computer has made, right? And then we evaluate, and then in our head we modify. Is it that? And then again we think, okay, I'm gonna change more green or this, and then I'm gonna be happy. And then again we go through the loop. It's just basically your iterative loop. And you see also some of these terms like from design of everyday things, right? So like the gulf of evaluation, and I forgot the gulf of, I can't really read it on the slide. But yeah. sort of like our standard iterative loop on creating content as game developers. Golf of expectations. So this was a super quick intro to the term, to some of the works that are out there, and some of the design patterns and challenges that exist. Again, the paper has a lot more detail. So if you want to start to look into this, how can I create something that gives me feedback other than just create something I can work with as a colleague or coach, or even just someone who can help me do things. The term that we often use is the mixed initiative, because you have initiative changing between the AI and the human. So the human can take the initiative, but also the AI. It doesn't have to be the initial initiative. It can also be just another round in that iteration loop, right? The human creates something, and then the AI picks it up and says, "Oh, but what if you did this?" And then you say, "No, I want to do this." And then the computer, okay, then you can do this, and so on and so forth, right? If you just want to play around with it, Casual Creators is a great place to start. Again, Kate Compton, she has a ton of really great examples on her website. And Casual Creators is sort of like a specific genre of procedural content creation where there's more emphasis on the process and the act of creation to be something that is a pleasurable thing rather than on the outcome itself. So it has to be nice and pleasurable to create. But that's a really nice way to start with thinking about how can the AI work with the human. So as an academic, I didn't really know if I should put the slide in. I had an animation that I didn't get permission in the end to use. So it suggested to me to look what happens in 5 years in this area. I don't really feel comfortable second guessing or predicting about the future. There's also, I'm from Denmark, and a Danish politician, Carl Christian Steinke, he wrote once, "It's definitely very difficult to make predictions, especially about the future." So I don't really know if that is something I should do. But I think we're already seeing machine learning be used for real-time rendering. So there's neural rendering. Neural rendering has become a thing. And we're also just seeing small things like NVIDIA has a denoiser, so they can create, you have an image, maybe like a global illumination image, you haven't cranked up the details or the number of rays, and it just has still a lot of noise in it. And you can just use a machine learning algorithm to remove all that noise, and it's gonna guess 99% correct what the illumination is going to be on those pixels that it smooths out. And then something I saw recently, which I thought was really great, is ability to work on animations. So you can pick out certain things like a car or character says, "Oh, don't you want green trousers instead of blue?" Or can I add a butterfly to the jacket while the character is moving? Which I think is makes it more and more interesting also for game developers. And then I think working with AI will become more and more accepted as not only as PCG, as procedural content generation, but also as having like a little AI that we work with, a sort of Clippy, but not as annoying as Clippy. Maybe we won't give the names. I don't really like that we have things like Siri or Alexa and things like that we give them names. But I don't mind that my program is trying to give me suggestions. Yeah, depends on where your comfort zone is, of course. So some of the sort of like more research challenges is that these UIs often, when you see these applications that that you use to interact with procedural content generation, often have like a ton of sliders. But actually, as developers and creators, when you create a 3D model in 3D Studio Max, in Maya, you use direct manipulation, which means you just work directly in the space. You use your mouse to drag and work directly on the model. Or if you work in Photoshop and things like that. So there's still a lot of work of these applications to let you work in the same space. So the AI works in the same space as you do, right? So you want it to show you suggestions, and you can modify the AI suggestions in the same space, instead of I'm working over here, and then the AI is giving me suggestions over here, and I pull some non-intuitive sliders, and then it comes up with suggestions for me, right? You want it to almost work like a human being on the other end, like sort of like a collaborative 3D modeling program, if that's your domain, right? So someone is working with you in that space, or maybe if not modifying your model directly, and maybe highlighting things on it and say, you can just click here, and I'm going to create a leg for you exactly like you wanted it. And of course, this challenge becomes even larger once we move into AI, right? Now, sorry, into VR, because there we already know that we want direct manipulation. UIs, abstract UIs are almost gone in virtual reality. So if we want to interact with an AI, it has also to be non-abstract, right? So there's a lot of challenges in that space still. So one idea that I really, really liked, that I think can also help us be more creative, is the ideas about disagreeable AIs that Gillian Smith, she asks, how would these AI-supported tools work if they were designed to be disagreeable with their users, and argues that if in fact it is in our interest to design tools that are based it is in fact not in our interest to design tools that are based solely on productivity and efficiency, right? Because it's not only about getting something done fast, we want quality, we want time to reflect. So she proposes that if we want some truly reflective design processes, then it might be in our own interest to design a mixed initiative tool, AI-assistive tool, that encourages deliberation and for the design process to take time, right? So instead of sort of like the AI trying to second guess you, it's you want more green, or I can create this wing for you, and do you like this pattern? I bet you like this pattern because it's similar to what you worked with before. It might say, no, why don't you do this other thing instead? How about that? Have you looked over here? So to create more diversity or other things in that direction. It's an interesting thought, at least. It'll slow down the work process, which might be hard to convince your boss about, but it might create better content in the end, or more interesting content. So today, what we've been talking about is the motivation for this talk, which is that PCG doesn't always, or very rarely actually save you money, because our ambitions grow, our teams are growing, we're spending more money on content, even though we have these powerful tools. Our teams are enormous, but maybe instead we have to look at them as PCG tools, as tools that can work as creative partners with us. Then there are some examples, some different ones. The top 5 are level designs, game production tools. Galactic Arms Race has create procedural content on the fly in the game. So this is what we call offline generation and online generation. And then GitHub Copilot is for coders, and then we have the new fancy image generators based on these enormous language models. Okay, and then a bunch of references that I used in my talk. Yeah. So that's it. For my own research, I'm working on this kind of tool for creating an animation tool, modeling animation tool, AI-assistive animation tool in Blender. So please tweet at me if you're interested in joining. Hopefully, we're going to be able to test something in the autumn. I'm on parental leave at the moment, but hopefully in the autumn. Yeah. Any questions? Yeah. Oh, there's a mic coming, I think. Sorry.
Thank you. Obviously, procedural generation is a mainstream thing in games. Do you have a sense of how many of these tools are starting to shift to become AI procedural generation, and what that shift actually is?
It's sort of different. It's a difficult question because in my mind it's the same thing. So procedural generation is AI, right? So it's more of the methods that they implement is that methods that sort of like make you reflect more on what you've been doing. For commercial tools, very recent ones that I haven't seen a lot, but I'm sure there might be some out there. And yeah, no, I don't know. Yeah, it's the answer. Not very recent stuff.
I think your point about disagreeable AI is very interesting, but also it sparks questions about the degree to which creative people will be participating. I mean, especially if the AI are actually kind of like overriding and disagreeing with your decisions. How do you imagine this reshaping creative roles?
So for me, it's more. I think we'll always want the human designer as the final arbiter, at least in most cases. Maybe if you're creating something like a super casual where you can create an AI that works on like market-led approaches or things like that. But most of the time we want the human to decide what, right? I think it's just about allowing ourselves to have an AI that disagree with us or feeds back ideas, instead of sort of like being a little bit annoyed with it when it comes up with suggestions we don't like. And it's just saying, so it's more about the work process. I think it will change, but not who decides in the end. I don't think it will. There's no danger of PCG tools replacing the human artist or the human coder. I think not with these kind of like creative decisions, at least. Yeah.
Thank you. Well, thank you very much for a very inspirational talk. I'm very curious about that generation of this set of solutions or alternatives which you present to the user, and what sort of criteria would you use to make sure that these suggestions are actually useful for the specific problem you are trying to solve. And also, you mentioned that the AI is well, checking whether what you are doing satisfies the set of constraints, and would you consider useful to give the user control over these constraints as well? So they're not like set on the system, but you can actually also play with these constraints. Thank you.
Yeah, certainly. I mean, these set of constraints are often very application specific. So there's been a lot of different research in saying, should we create some suggestions that are not only based on what the user is doing, but they could also be based on aesthetic criteria, or for example, if you have something where you're creating, let's say, 3D models of furniture for a house, it might also have something with the weight distribution. So of course, it's incredibly application specific, and yet that will definitely need a human in the middle to adjust those kind of constraints, I think, because you have to be. It's the human and the team that knows what you're creating in the end, not the AI. So I think always these sort of constraints and goals will have to be adjusted for the game kind of stuff we're doing. Yeah.
Because when you mentioned solving a problem with lots of constraints, for me it just instantly comes to mind linear programming as a mathematical concept.
Yeah.
And are you aware whether this linear programming is also used in conjunction with AI to handle these constraints, to give the optimal solution for the problem?
If I'm not completely, I'm not totally sure. So a lot of these models nowadays use neural networks in one shape or another, but this one, I believe, is using a constraint solver, sort of just a straightforward constraint solver. You set up some constraints, and then if you modify the level here, it will recalculate the surrounding levels mathematically around you.
Thank you.
Welcome. Okay, no more questions. Thank you so much for coming. Yeah. you.